So we did subwoofers, we did speakers.
Yep.
Electronics?
Electronics.
Start with source.
We're talking about real marine, right?
Real marine, yes.
Real marine. Let's talk about an amplifier. What do we have to do on a marine amp? Oh, you know what? We've got to conformal coat them. Of course, we've got to put some gaskets on them.
Wait, Phil. What is conformal coating?
Conformal coating? It's a sprayed-on goop. I don't know. Give me a technical term for goop.
No,
Look it up.
Yeah.
It's a sprayed-on coating. When the board is stuffed and soldered and it's all assembled and ready to be put in the amp, before they put it in the amp, they will spray it and hermetically seal it against moisture, so that the electronics and the board and all its components are inside a layer of, well, goop.
Now, why? What does that do? What's the benefit?
It keeps moisture out of the sensitive electronic parts, you know, those little bitty integrated circuit devices and resistors and all the stuff that Joe Hobart talks about.
Yes.
It keeps them dry in theory. And it gives the labor guy, the repair tech, extra labor money because he has to scrape that off if he's going in to repair the amplifier.
True. And then he has to reapply it.
He's got to recoat it. Yeah.
Okay, so yes, conformal coated boards.
Yep.
Continue.
Gaskets. The controls are sealed on our KXMA stuff like we see here. We should have had this undone, but oh well. One thing though, those are all kind of preferences of things that we could leave out and not have to worry about compliance. If I turn this around though and point to our power connections, this is a point where for a boat to be built and to utilize these amplifiers, this power connection has to have a very specific feature, singular. The wire going into it cannot be directly contacted by that set screw that goes down.
So the set screw itself cannot twist into stranded wire.
Correct.
Okay.
Yeah. So if you look closely, you know, Steven's over there trying to get a set of Allen wrenches when he should be zoomed in on this amplifier. We'll critique him later on that. But if you look in, you guys have got KXMA amps laying around, I'm sure. Just grab one and look at the power connection. When you look inside there, you'll see that there's a little flat metal leaf. And what that does is it provides a barrier between that set screw and the power wire, which allows this to meet ABYC compliance. There's the book. And to be used for new boat construction. Legal, safe.
Legal, safe.
Yeah.
Okay, so, and the purpose of this is, if you take our aught gauge stranded wire and without tinning it or without putting a connector on it, those wires, strands, can splay.
They can splay. They get crushed when you crush copper. Copper will work harden. Anybody that hammers copper for a living, doing art or anything, they realize after they hammer it for so long, it gets hard, it gets brittle.
Yeah.
And you have to reheat it to anneal it.
Ah.
And so the same brittleness can occur in a wire, and that's where the ABYC, the American Boat and Yacht Council, says brittle wire on a boat's a bad idea because brittle wire can break.
And then you've got arc potential.
Right.
Spark potential.
Right.
Yeah. Okay.
Right.
So, and these are the fine details that make Kicker real marine.
Yep.
Real marine grade.
Real marine.
That's, and the safety, back to safety again.
Absolutely.
Okay. And let's talk about stainless steel real quick, because a few episodes ago there was a discussion about stainless steel, which got real funny real fast. There are different grades of stainless steel.
Okay.
And we use, which one do we use and why?
We use 316L.
Okay.
I don't believe it's the highest grade of stainless steel, but it's really good stainless steel. The 316, that 316 number specs out how much chromium gets mixed into the steel to provide corrosion resistance.
Okay.
And then that L on the end means that it's a pure product that goes in to be manufactured. L is L for low, as in low carbon.
Low carbon.
So we've got as little carbon, plain steel that can rust in it as possible.
Now, the cheaper, what's it, 304?
304.
304 is sort of the next grade. And so for some of the off-branded companies or some of the budget-friendly, you might be looking at a 304. So when you open the package, it looks like stainless steel.
Sure.
But then you screw it into your boat, and a few weeks later, you've got something running down.
Rust.
Rust.
And certainly in the marine environment, somebody in a freshwater lake using 304 stainless, they're going to be in good shape for quite a while.
Okay.
However, though, if you go out and you're in the salt water and you're hosing your boat down with salt water, you got 304, it's going to rust straight.
Going to rust real fast. Okay.
Yeah.
Okay. So that's a little fine detail, not necessarily safety related, although you don't want your screws breaking off. You don't want this bracket to fail.
No.
At 100 miles an hour.
True.
So it is safety adjacent.
Yes.
But it's longevity, really.
And there is a tidbit I want to share with you installers, and while it may be a real pain to consider, you can migrate plain carbon. Say if you've got an old screwdriver that the chrome is worn off of the tip on your Phillips screwdriver that you use every day for everything.
Yeah.
And you go using it on stainless steel screws. You can migrate your plain carbon steel from the tip of your screwdriver into your stainless screws, at which point you do cause the stainless steel to rust. Whoa. And a lot of times people will complain and say, I've got stainless steel on my screws, how come they're rusting? So my tip for all of our installers out there watching, get you a dedicated set of nice triple chrome plated tools, Phillips head screwdrivers, set those aside, label them, keep them away from your garage monkey, and only use that certain set of tools on your stainless steel stuff, like the clamp on this here tower speaker right here.